r of x, r for rational, and looks like this. 2x squared, subtract 5x plus 2, all over x squared subtract 4. Now, someone who may have that handout handy, all these handouts being given to you, is that short of one of those at the bottom? Okay, I have not done this one, I don't think yet. Now, when you see one of these, I will have typed up on the exam, I'll have the steps to follow. Okay, there's a series of steps we went through in class. Step one, some students may recall what I was asking for first. I think the first thing was what? Domain? I think. Now, I know me, though. I would say, Professor, why don't you go back and simplify, if you can, this rational function. It might be easier to graph if you simplify it. And I think in this case, the numerator, I think, will factor. You guys can help me. Well, the 2x, x, probably a minus 2 here. Let me step back and a minus 1 there. And my x squared subtract 4, it's called a difference of squares. That will factor. It looks like that. Now, what is the difference right now that you notice at this point on this one compared to the other two we did earlier last week? What's happening on this one that did not happen on the other two?
We cannot have minus
So
x
again.
equal to. We cannot have x equal to.
Beautiful, I'll say that for something else. Oh, hang on just 1 second. We'll get that domain out of the way. He's gonna be right quickly. Professor, you look at the red right now, I know you cannot let x be a 2 or a negative 2. That's what they want. They want you to recognize that real quick. That's my domain. You can't let x be a 2 or a negative 2. But I see something else happening.
Yeah, we have same in the numerator.
Yeah, well, can I do this?
Yes.
Which I could not do on the tube last week. It didn't happen like that. Sometimes you'll get factors to match up and cancel. And that means now we're just gonna make it easier on me and you when we graph this. Now we're down to this. In terms of graphing. But the domain stays like this. Just recognize that domain in the original. Number 2, if I recall correctly, it says simplify it. Guys, before I simplify it, I'll just rewrite it. R of x is equal to 2x subtract 1 over x plus 2. No problem. Number 3, if I remember correctly, I think it was the intercepts. Find the x and y intercepts. These are lengthy. Guys, the x-intercept, of course, merely go back and replace r of x, which is y, by 0. We'll use the simplified version. And I'll put a comma there if you want to solve that. A little cross multiplication. And in fact, you'll end up with 2x subtract 1 is equal to 0. And if you solve for x, then we end up with 1/2. You guys agree?
Yes.
Okay. So at this point, I have an x-intercept, just 1, at 1/2, 0. Y-intercept, we find r at 0. Go back and replace all the x's by 0. If I do it here, I always use my simplified version. Looks like I'm gonna get a negative 1/2. See, you guys might agree. So that's my y-intercept. Interesting. X-intercept is positive 1/2, y-intercept is a negative 1/2. So far, so good. Number 4, now, and we gotta be careful. Are there any of these so-called vertical asymptotes that do something to the graph when they get close to them? If so, where are they located? Does anyone recall how to find if there are something, how to find them? You set the denominator equal to 0 on that handout. My denominator is this. Someone have a vertical asymptote at -2. Horizontal. Did I show you guys the process of finding the highest degree and dividing everything by that degree and then simplifying from there? Is that, I think I did that in class, didn't I?
Yes.
That? Also, look at this, and you may use it, a little shortcut on the horizontal, if these match up, which is the best case in the world, if the degree in the numerator, highest exponent, matches up with the degree, highest exponent in the denominator, which they do in this case, your horizontal asymptote quickly, not a shortcut, is merely this number, coefficient, over this coefficient. So if I want to use that, that's 2/1, and that's 2. Or you guys could use that division by the highest exponent, and so forth and so on. Yes?
I thought the vertical asymptote would also have a positive 2 from
Beautiful,
before we
beautiful.
simplified it.
That's exactly what I want to hear. Now, here's the concern. You said, Professor, you mentioned the vertical asymptote from the simplified version is x equals -2. You said that denominator equals 0 to find that in. Now back here though, the concern is, I thought you had an x minus 2 in here somewhere, Professor. Did they cancel? Yes, what's happening, and I know what the student wants. Professor, why did you not also consider, where was it, back here, horizontal, vertical, back here. Why did you not also consider, don't put this yet, guys, the x minus 2 also, which was down here in my denominator, and get another vertical asymptote, which in this case would be another one at 2. Why, Joseph? They cancel it out. Thank you. Now, if they cancel out, something happens on the graph, but it's not a vertical asymptote. So we lost one of the vertical asymptotes by that cancellation. What does happen though, I'm so glad you brought this up. There's a good response there. What happens is, if you get a cancellation, and we did, this tells me, which we have not seen in this class, one of these yet, there is going to be a hole on the graph. Oh, you know what, I think I did in my discussion, showed you one with a hole in the graph. And that hole in the graph is going to be, take that x subtract 2 that we were talking about earlier, set equals 0, and you end up with x equals 2. So guys, it's going to be a hole on the graph at 2. So we have vertical asymptote at -2. So don't confuse the two. So you get a hole on the graph if a factor cancels. And sometimes it does, and in this case, these two canceled, and therefore I have to consider that to get a hole on the graph. By the way, I'd like to know exactly where that hole is located when I get to the grid. I know it's out at 2, but I need another coordinate. I need a y coordinate to locate it. Does anyone have an idea how to find it? How can I write the complete whole coordinates? I know x is 2. What can I do?
Put 2 back into the
Right there, you place x by 2. Okay, so I place x by 2 right here, we end up with, looks like 3 on top. 2 times 2 is 4, minus 1 is 3. How was that, 3/4? So now I know the precise location of the hole on the graph. Jeez. Now, so far so good? I think I went through the steps that I showed you last week on this one. Now, let me point out something else that I had not shown you yet. It may happen here, it may not. Back on that horizontal asymptote. And guys, keep in mind, I don't have to graph yet. When we say a horizontal asymptote, we're talking about a horizontal line that the graph sort of follows. That's like in behavior out here. That's why it's there. Guess what happens sometimes with that horizontal asymptote as the graph follows it. And you have not seen one of those yet done by me. And I don't know, let's see what it says here. It crosses. It may cross that horizontal. Look at this. You erase it. It may do what we expect, but you say, well, wait, Professor, it's going to follow that horizontal line. It is. But it may do this. And eventually cross it. But it stays close to it though. That's why it's there. So when it crosses, it's going to have a crossover point. It stays close. And something like that, still close to that red horizontal asymptote. It does not do this. It's got to stay close to the asymptote. And sometimes it'll cross. Now, does mine cross the horizontal asymptote here? Can anyone tell me before I leave it? Let's check it right now. At 2, will my graph, when I start graphing, cross the horizontal asymptote at 2? What can you do as a clever student to find out before you get to the grid?
Set it eligible.
Do it again, close, do it again.
Would you set the whole equation equal to?
Well, we'll set this equal to something and find, do they sure enough, do they cross my graph and the red horizontal asymptote? Do they, is there a point in common, a crossover point? We'll set 2, the horizontal asymptote equal to what, guess? This one. Equal to the function. Here's the graph. This is the function. So we'll set this equal to 2x subtract 1 over x plus 2, and see if they have something in common. That's my horizontal asymptote and my graph, my function, have something in common. We'll solve it, we'll do a quick cross multiplication, end up with 2x plus 4. You guys might say cross multiply like this, you guys could use a common denominator. And in the other direction, it was at 2x subtract 1, and we lucked out here. Well, the 2x's cancel. Yes or no? Okay, and I have no x's to solve for. So that tells me no, there is no crossover point. The x's canceled out, I can't even solve this thing. I tried, can't do it, therefore there is no crossover. None on this one. Now let's put all this together and see if I have what I need. Guys, when I go to the grid, now can I make yours for the exam busy, not too busy? You got other things on the exam to do besides a rational function. Here we go. Let's go back and start picking up items here. Go with the x and y intercepts. Let's get those out of the way. There's an x-intercept at 1/2. So let me mark this now. There's a y-intercept we discovered earlier at -1/2. I'm going to mark it now. Right there. I'll squeeze that in. The vertical asymptote, I have only one. It's out at -2. And let me be patient here and put that in as the vertical asymptote. Your graph can never, never, never touch a vertical asymptote. Never. It can cross the horizontal, but it can never touch the vertical. Okay, got that. Had only one. Interesting. Vertical, horizontal. Horizontal's up at 2. Put that in. And up here, let me try the green. The green will work for me if I keep all this straight. Here's my horizontal. And interesting here, this one has a hole in the graph. So let's get that hole there already plotted, ready for us. Out 2, up 3/4. Put 2 here. Up 3/4, guys, I'm gonna say it right in here. Look at this, how strange. There's gonna be a hole in the graph. Out 2, up 3/4. Now, I need some help. How many pieces to this graph are there the way the graph looks right now? The grid. How many pieces to the graph am I looking for? There's only 2 pieces. Something happened to the left of that vertical and something happened to the right. Those verticals determine how many pieces. The guys to the left, over here, of that red, does anyone have a guess as to where that piece of the graph must be located? And you can plot points. Does anyone have an idea where it is right now at this moment without plotting points, even though you could plot points? Go for it.
in the top left.
It's gotta be. Why must it follow those asymptotes? That's why those asymptotes are there. You gotta follow those. Why did you not tell me? Maybe, Professor, it's, we don't know yet now. It would do this, guys, so look at this. It follows the green and the red like this. That follows the green and the red. Why not that piece?
Needs to reflect the graph, mirror.
No, something else.
There's no intercepts.
Yeah, you're gonna pick up another x-intercept. Let's go across the x-axis again. There are no other x-intercepts. I found the x-intercept back there. That cannot be there. But you can always plot points also, to make sure. No. Now, on the other side, we'll be finished. On the other side of that red, the other piece, I've got to pick up this, I got to pick up this, and my graph must follow the red and the green. Any ideas? Pick up those two black points, follow the red, follow the green. I don't think I had much of a choice. What do you think, guys?
From right up to.
Okay, start here,
From here to.
or where do you want to start? Oh, you gotta pick up this, you gotta pick up this, you gotta follow this, and you gotta follow this. I have no choice. I don't think that, I'm gonna start here. Goes up, gotta pick those 2 points up, and on up, and follow forever that green horizontal.
And it doesn't like go directly around the hole in the graph?
Beautiful, beautiful. Now, that's why I did that. Are we finished? She said, no, Professor. You're supposed to show us what? There's a hole on the what? Graph here. She says, don't do that. I think you do this. You better not go around, you gotta pick up this. Go through like that, and then on out, and it sort of follows that green. So it should rise up and go toward the green. Now, did I pick up my x-intercept, y-intercept, and also show the hole there on the graph? You gotta show that hole in the graph, yes. There's the graph, guys. It's done. Now, could you do one like that for me? Friday. Could you show something like that? Let me step back and look at it, because there's quite much work to be done here. Any concerns before I leave this one, guys? Now let me ask for the domain and the range, if we can answer it. I've got the domain already. Range, since the graph is there, can anyone make, can anyone make a guess as to what the range, the up and down might be? How far down is my blue graph dropping? And how far up does it go? And be careful, Phil, go for it.
Is it everything except for 2?
Okay, it does not touch 2, so give me an interval notation.
Negative infinity
Negative infinity up to what?
2, up to 2.
Okay, I see something you better be what, careful about.
Oh, up to.
There's a hole there.
3/4.
Uh-huh. Up to 3/4. Union, now finish it up. Then from that point, where's it going? Is it going up toward the green?
Yeah.
So union what? 3/4 up to what? 2. And we're not finished. Then it's above 2, right here. And then I need one more interval notation, that would be what? 2 through what? Infinity. Yes or no? Wow. And there's my range. We've got the domain, the range out of the way. Guys, I'm gonna ask you all kinds of questions here. I will ask you this though, before I leave it. Here's the original function. We cleaned it up. Here was the original function. This is its graph. This is this picture. This is the way that function over there looks. Someone help me out here. Here we go. Suppose on your test, I have on the side here, please find the value for this. I want R of 504. You say, Professor, are you nuts? You're telling me to go back and replace all these x's by 504? Or I could use a simplified version. Where was that simplified version? Right here somewhere, right here. Can I put it here? 504? And I could, and 2 times 504, and we'll get that math and done, we could, in the simplified version, and avoid this one. But does someone see it quicker? Actually, what is R at 504? Is there something staring at you right now that would say, Professor, I can tell you what it's very, very, very close to. Why?
Because it's,
Does this thing go on out forever? And I'm asking that, 504, is this graph, blue graph, gonna go up, up, up toward that green and get really close to it, way out here? So at 504, you're very, 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 very close to that green horizontal asymptote at 2, you agree? So this is approximately, Professor, it's approximately 2. And in fact, since a student asked me, if I put in 504 right here, just do the math real quickly. Twice 504, guys, watch me mess this up. Is that 1008? Is it 1008? Then subtract 1, oh my goodness, that's what, 999 something? Is that true?
wait,
Oh, is it? And then over what, 504 plus 2, what is that, 506? And you can divide that out and see you are close to 2. But why not look at the graph? That's why the graph is there. Okay, now I'm leaving that. Any concerns, questions? Yes?
How big of a number would that have to be in order for you to be able to approximate?
Wait a minute, I didn't quite hear.
Like, how far in the graph do you have to be in to be able to say is about yes?
Ah, good. Now you're talking a little calculus here. Good question. She's asking, Professor, how far out must I go? You're gonna be a large number, so I know way out here is awfully close to that, green. She says, but if you gave me something way back here, maybe it's not as close to 2 as it is way out here. No, I'll have to give you a big number. I want way out there. So it's very close to 2. Okay. Some students have asked this also. They'll say, Professor, I know it does not cross the horizontal asymptote. We tried it. But suppose it did cross out here somewhere, guys, like this. Our graph is beautiful though, but if it did cross, let's say put it up like this, and eventually crossed, it's gonna hover around, stay close to, even at that point. It's still going to stay close to what? 2, isn't it? Except it's above. I'm still close to 2 though. Okay. Got anything else on this one? On a Monday? Are we okay? Now, I have one more I think to work out. I think we better just save that one until tomorrow. I got one more to look at, because I think that remaining one, the graph does cross over. Do I just have one more? Well, maybe also one of those with an oblique, which I have not discussed at all yet. It may have an oblique asymptote, not a vertical, red, not green, horizontal. Look at this, how crazy. It has an asymptote like this, a slant, and the graph falls. So I better save that till tomorrow. Guys, any concerns? But this is where I am then. We're gonna come back and pick up that last problem for you guys tomorrow. This one's finished. I thought we did a good job on it. Please ask, especially with the hole on the graph. That sort of threw this off a little bit. Okay. Now, what I need to do is definitely again commend the class on those scores. That last exam. Okay, guys, I think I'm ready for this. Let me check and see, let me go to myself. Beautiful.